Okay, I'm going to go to try to clump these in groups of 10. Let's see, I got to watch the time. So it's, all right. Okay, complete combustion of a sample of hydrocarbon in excess oxygen produces equimolar quantities of carbon dioxide and water. Equimolar means that the moles in front of carbon dioxide and water have to be the same. So very quickly, because you guys have 90 seconds of problem. CO2 plus H2O. If I go to balance this, switching colors, 2 carbon, 1 carbon, I need a 2. 2 hydrogen, 2 hydrogen, I need a 1. Stop here. That is not equimolar. C2H6 plus O2 goes to CO2 plus H2O. There's a 2 here, so I need a 2 here. There's a 6 here. I need a 3 there. I'm going to stop right there. I haven't even balanced the oxygen, but it's not equimolar. C4H8 is going to be the answer to this problem. CO2 plus H2O. I go to balance it. 4 carbon, 1 carbon. I need a 4. 8 hydrogen, 2 hydrogen. I need a 4. There's my equimolar. It's looking like C is the answer, and then C6H6 plus O2. Now notice, I'm not balancing the oxygen, but who cares? You got 90 seconds of problem. Don't balance something that doesn't need to be balanced. You can see immediately by looking at this pattern, this is always half as much as this. You know, if this is a 2, and this is a 2, then this is a 2 and 1, and this is a 2, and this is a 2, and this is a 6, which, and half of 6 is 3. And so you can see right here why this one's going to work if you understand this problem. And then 6 carbon, 1 carbon, I need a 6. 6 hydrogen, 2 hydrogen, I need a 3. Obviously, the answer is, let me make sure we're recording this time. Okay, I did that in 2 minutes, not 90 seconds. Okay, so now this problem, this is a crazy problem. Which has the weakest intermolecular forces? Okay, this one has the highest vapor pressure. It either has the strongest intermolecular forces or the weakest intermolecular forces. And I submit to you that it is the weakest. And here's why. If you remember how vapor pressure works, you put a liquid into a container and you freeze it. And then you hook it up to a vacuum pump and you pump out all the air, so there's nothing here, and then you let this melt. And some of this liquid turns into a vapor, and some of the vapor then recondenses. And when the pressure stops changing, it's at equilibrium. Now, what you need to know is when a liquid has a high boiling point, that means it likes to be a liquid. It doesn't want to boil, and so you have to put a tremendous amount of energy in because it has strong intermolecular forces. Now, vapor pressure is just the opposite, because if a liquid has a high vapor pressure, that means it likes to be a vapor, not a liquid. And that means it has weak intermolecular forces. And so this one has the highest equilibrium vapor pressure, so it has the weakest intermolecular forces. All right, guys, I just got to tell you about this problem. Notice, charge, charge, charge. Okay, Zn plus 2, Ca plus 2, and Ba plus 2 are all alkali earth metal ions. And you are going to drop them into water, and we want to know the relative strength of attraction. Now, I need you to know that zinc ions, calcium ions, and barium ions are all charged particles. Water is not a charged particle, but it is a crazy molecule that is polar. And because oxygen wants electrons so much more than hydrogen, the electrons shift this way, and the oxygen has a negative side and a positive side. And so this ends up being, when we talk about this ion, it's called an ion dipole force. Ions have charges, and dipoles have they have a positive side, a region of positive charge and a region of negative charge. And what drives all of charged particle forces is Coulomb's law, which is the force of attraction between two particles is a product of 3 things. and this K just makes the equation equal. The magnitude of the positive charge times the magnitude of the negative charge over the distance squared. And I got to tell you, in this problem, these guys aren't coming into play because 2, 2, 2. This problem is all about distance, and that's why they gave you these radii. Because how Coulomb's law works is the distance goes in the bottom. If you have a big number and you square it, it's even bigger. But when you divide by a big number, the force is weaker. So this is the smallest. This will have the strongest force. And this is the largest, so this will have the weakest force. And so the answer to this problem is this. Here is the strongest force of attraction is zinc with water, and then calcium with water, and then barium with water, because smaller ions have stronger Coulombic attraction. Coulombic attraction is a fancy way of saying Coulomb's law. And Coulomb's law only applies to charged bodies. This electronegative, you know, it sounds good, but guys, electronegativity is defined the relative tendency of an atom to attract electrons to itself when it's bonded to another atom. Electronegativity is only discussed inside an atom. Like we'll talk about it inside the water molecule. What's going on when these two atoms hook, you know, when two atoms of hydrogen hook to one atom of oxygen to make a molecule. Okay, so the answer to that one is A4. Okay, I love this. Zinc is used to reduce other compounds. Okay, so what does reduced mean? Oil rig, reduction is gained. So when a compound is reduced, it means it gets electrons. And this problem is telling you is zinc is often used to give electrons to other compounds so they can be reduced. Now, which of the following would be the best choice? Now, guys, this is an electron configuration argument. Sodium has an electron configuration of neon 3s1. And H plus has, now that's what you do. Hydrogen is 1s1. Plus 1 means it gives its only electron away. A hydrogen ion is a bare proton. By the way, that's why acids are so incredibly dangerous. Potassium is argon 4s1, but this isn't potassium, it's potassium plus 1, so it gave this electron away. And chlorine is neon 3s2, 3p5. But this -1 charge here means that chlorine picked up another electron. 5 plus 1 is 6. This turned into argon. Now, which of the following species would be the best choice to pair it with an atom that wants to get electrons? Well, guys, it's not this one. It doesn't even have an electron. How can it give them away to something else? And it's not this one, and it's not this one. This one has a noble gas core, and so the only answer that makes sense is A. Okay, hydrogen bond. I love this. Let's talk about water again. If I draw water, it looks like this. It has two unshared pair. It's an AB2E2. Oxygen wants electrons much more than hydrogen, and so the oxygen side of the molecule has a negative charge and a positive charge. And which one of these correctly represents hydrogen bonding? And let me just say this. Okay, so hang on. What do I got going here? How come I can't see? All right, so where's A? Oh, there we go. All right, it's not A. This isn't even a hydrogen bond. This isn't an intermolecular force. This is an intramolecular force. We don't even call them intermolecular forces. We call them covalent bonds. So it's not that. Obviously not this. Opposites attract. The two negative sides would be repulsed by each other. It's not this. The two positive sides would be repulsed to each other. The correct answer is D. Why? The negative side of one water molecule is attracted to the positive side of the other. That's what a hydrogen bond is. A hydrogen bond is a special kind of dipole-dipole force that only involves molecules that have hydrogen directly bonded to oxygen, nitrogen, or fluorine. And it's not this bond, it's the intramolecular force between them. In a kinetics experiment, it's set up to collect the gases generated when a sample of chalk is added to a solution of ethanoic acid, which is called vinegar. The rate of the reaction between CaCO3 and CH3COOH is determined by measuring the volume of the gas. And the gas that comes off, carbonated compounds kick off carbon dioxide. Now, the faster this reaction is going, the more gas that comes off. And so it says, which of the following experimental conditions is most likely to increase the rate of gas production? So they're asking you which of these things, if you change them, would most likely make the reaction go faster. And it's not this. Decreasing the volume of ethanoic acid would actually make the rate go down. Because remember, increasing the concentration makes it go faster because there's more collisions per second. Decreasing the concentration of either reactant makes the reaction go slower because there's less collisions per second. Decreasing the concentration of ethanoic acid would not make the rate of gas production go up. It would make the rate of gas production go down. Decreasing the temperature. Now, remember, this is not at equilibrium. It only goes one way. And one of the things we know is the reason why people have refrigerators in their house is, in general, the colder it is, the slower the reaction goes. And we understand now, as chemistry students, that it's harder to get over the hump if you're going slower. Also, if you're going slower, they're not moving as fast, and so they don't collide as often. Finally, decreasing the particle size of the CaCO3, that's the only thing that would make the rate go up, because in order for the vinegar and the chalk to react, they have to touch. If you have a big chunk of chalk, like a gymnast chalk, you know, a big chunk, and you put vinegar on it, the chalk in the middle doesn't touch the vinegar, so it goes slower. So basically, when you grind this into a fine powder, you're actually like making the region where they touch bigger, and it increases the rate of reaction because it's kind of like you're increasing the concentration of the CaCO3. That's the only one that makes sense. Okay, this one, I just think that this problem put in a bunch of junk that you don't need. Like, who cares about these and this? But I'll tell you why. I just think this is stupid, because the question is, at 450 degrees, you have 2 moles of each of these in a 1 liter container. So this is 2 molar, and this is 2 molar, and this is 0 molar. And then the question says the value of Kc is 50. So obviously we're not at equilibrium, because right now we'd be Hi squared over H2 times I2, which would be 0 squared over 4. So we're not at equilibrium. And the question is, what's going to happen as this moves towards equilibrium? Well, there's none of this. These are going to decrease, and this is going to increase. And that's really all you had to know. So will more H2 and I2 form? No. As it goes to the equilibrium, some of this is going to go away, and more of this is going to come. Will more HI form? Yep. Will the total pressure decrease? No, the pressure will not change ever, because 2 moles, 2 moles. The only types of reactions where the pressure increases or decreases is when you have something like a gas and a liquid come together and make, you know, well, we don't have to go that nuts. When one side has 2 moles of gas and one side has 3 moles of gas, well, when they're different, you know, as it moves this way, the pressure goes up. If it moves this way, the pressure goes down. But nothing's going to happen when the moles on each side are the same. And then the no net reaction will occur because, and this is not true, because what this symbol means is that the forward and backward reaction are both going on simultaneously. They're going on at the same rate, so you don't see anything changing, but the idea of dynamic equilibrium is they're both going on. And so the only answer that makes sense there is B. Okay, I did this one with you before. This is called a Boltzmann distribution, and it's just like a big old Big old bell-shaped curve. Okay, the speed distribution of molecules in a sample of gas at a certain temperature. Which of the following graphs show the speed distribution of the same molecules at a lower temperature, meaning it's getting colder? And it's obviously not this one because the average speed went up. It's supposed to go down. It's not this one. The average speed didn't change. When it's colder, it's supposed to go down. It's not this one. The average speed went up. It's supposed to go down. It is this one. The average speed, so the temperature here and the temperature and this is not really temperature, but it's because there is no temperature, but as the temperature goes down, the speed goes down. So at the lower temperature, which is the dotted line, the average speed is slower than at a higher temperature. And then remember, we talked about this is all about calculus. If the number of molecules doesn't change, the area under this curve and the area underneath this curve has to be the same. And so obviously, if this has a lower temperature, in order to be equal, it would have to have a higher peak. And so the answer to this problem is D. Okay, and then 9, this one's crazy. This one takes, because we did this a long time ago. We have two things. We have a metal, we have water. When I was teaching you this, I told you to go Q, M, C, P, T final, T initial. And then I'd say Q, M, C, P, T final, T initial. And you don't really have to do all this. I'm just trying to explain it. And so we have a 100-gram sample metal transferred to an insulated container containing 100 grams of water. And we don't know the heat capacity, but the final temperature of the system was 35. The initial temperature of the metal was 100. The initial temperature of the water was 22. And so if you look, this temperature goes up 13 degrees, and this temperature goes down 65 degrees. Notice the masses are the same. And then the thing that draws this together is that any heat lost by the metal, and by the way, the metal has to lose heat because it started at a higher temperature, and heat is the transfer of thermal energy between two bodies at different temperature. Any heat lost by the metal has to be gained by the water equals 0, and that is huge. That is called the conservation of energy. It's the first law of thermodynamics. Energy cannot be created nor destroyed. Keeping that in mind, this answer is stupid. Therefore, the metal lost more thermal energy than the water gained. Nope. Energy cannot be created nor destroyed. If we could create energy, we would just create energy. We wouldn't have to worry about coal and gasoline and nuclear power. Again, the total energy of the water and the metal decreased. That doesn't make sense because one went up, one went down. The answer is B. The metal temperature changed more. It did. The metal temperature changed more. Then the metal temperature changed more than the water temperature did, but the metal lost the same amount of thermal energy as the water gained. That is huge. That's true. And then why is C wrong? The metal temperature changed more than the water temperature. Therefore, the heat capacity of the metal must be greater. No. Remember Q lost and Q gained? This number is so much bigger than this number that in order for these two to be equal, one's positive, one's negative, so ignore the charge. Like if this is negative 310 joules, this would have to be positive 310 joules. So ignore the charge, just look at this. In order for these to be equal, they have the same mass, but 65 is so much bigger number than 13. This is going to have to be a small number, and this is going to have to be a bigger number. And so this doesn't make sense. So the answer is B. All right, and we talked about this one. This is supposed to get, they thought it was a mixture of iodine and tellurium, but the question says which would be the best basis for concluding that the sample was pure TE, and otherwise there's no iodine in there, it's all TE. And then C says iodine consists of only one isotope and it has 74 neutrons. Okay, and if you look on the chart, iodine is atomic number 53, which means it has 53 protons and 7 and 12, and so the mass of iodine is 127. And how you can be absolutely sure that this is a sample that just consists of iodine. If you look at our graph, okay, you're being funny. There is nothing at 127. So that is the best reason. I have no idea what I'm doing here. I'm going crazy. All right. I just screwed that up. All right. I think this is 11. I said I was going to do 10 at a time. So let me turn this back on and